Hey guys, welcome back to another video. Today I'm going to be putting together a new series of video articles. This video article series is called Mass, Matter, Function, Interaction of Momentum. This video series will have four main parts, or 4 parts, and it will also include several posts that actually came before I wrote down the 4 main parts. So it will be broken up into about 6 or 7 video articles, and will cover in detail the research, work, and the seminal formulations I was coming to in late 2015 when I was realizing that the universe was not as simple as the way it has been described and taught in science class. I was beginning to understand things like quantum mechanics, concepts of gravity, space-time, the Higgs field, and things like dark matter, dark energy, and I started to realize that the nature of reality is a lot deeper and more complicated than initial observations. Things like quantum entanglement, the nature of dark matter, dark energy, and the expansion of the universe, as well as really exotic and weird things like Bose-Einstein condensate, as well as concepts of crystals being designed and used for quantum computing, and of course, thermal and fluid dynamics. Now, these particular posts were originally written on a science website forum. The science website I was looking at had an article about a star traveling through the universe at a very high rate of speed. The star was very energetic and it had a shock wave in front of it, as well as a long tail of energy visible behind it. The star was moving through space at an incredible rate of speed and it was very energetic. So, with my mind filled with the new knowledge I had recently been acquiring in my quest to learn more about the fundamentals of nature, and specifically the idea that matter gets heavier the faster it moves, and I saw that the star was not only moving through space very fast, but it was also tremendously energetic, and I pondered the question, if the star was to quote-unquote slow down, would it get lighter? If something gets heavier the faster it moves, then clearly it would get lighter if it slowed down. Right? That was my basic thought, and I really believed it would be a unanimous yes. Now, there were a couple of replies to my post. There was a little back and forth, but there seemed to be no indication from anyone on this forum filled with quote-unquote scientifically inclined smart people to corroborate my simple tongue-in-cheek comment, of which I thought was so obvious it was actually a stupid question. So, because of this, you will see some quibs alluding to other people's comments on the forum that I have not included because they are not important, but you will notice. It won't be a problem because the information in my posts are self-explanatory, and once you watch the entire series, I think you will fully understand everything I was trying to say. And one more thing, as I said, these posts were written when I was just starting to formulate my new theory of, well, everything. And I had not fully grasped or formulated everything. And in fact, it was this very form and the lack of response or understanding that forced me to just stop and write it all down as clearly as I possibly could. And at the time, I had not fully realized the scope of what I was undertaking. And because of this, there are some things in these posts that are not complete, or even now I realize are not totally accurate. So just know that, and bear in mind where I was at in my journey of formulating these theories at the time. Now, with all of that said, I will start with part 1 of the 4 parts, and after the first 4 parts, I will include several posts that actually came before these 4 parts, as well as at least one more post, which I will call part 4A. That is basically a single paragraph that was written about 6 months later, where I state that I realized that while the universe is decaying, it is also expanding. And I truly believe you will find these new ideas and theories about the universe very exciting. Okay, so here we go. Part 1. United States, September 13th, 2015. Part 1. Relativity and space-time are the fundamental foundations for this theory, so it does not change much. Many equations are the same, it just adds to them. As for a round 1 sucker punch, conservation of momentum is falsified. To say an object in motion in space, with no other force or anything at all to hinder the movement of the object, will continue moving at the same speed and direction forever until it is impacted upon, is completely incorrect. Even at the lowest speed possible, if there is quote-unquote something that will prevent mass and energy from traveling faster than the speed of light, then that something is going to have an impact on all mass in the universe, including slow-moving objects. That was an hors d'oeuvre.
Conservation of energy shall not be violated!
But how true is that? Is energy always conserved? It's a big fat no, isn't it? It's more like a little itty bitty no.
And here we go. Seeking the questions you ask, we need to start at the top. or at the Big Bang. We need to ask, what is space? What is time? What is energy and mass, matter? And where or how did it all come into existence? To those questions, on the highest of levels, I cannot really say exactly where did it all come from and why. But starting from the Big Bang, I can extrapolate the evolution and convergence, the emergence and analytical consequence of the occurrence, and enlighten the path a little more. Based on our own reality, I can take the theory beyond our universe and elevate it to a higher dimension. And this all has to do with black holes. With the confirmation of the existence of black holes, something Einstein didn't have the luxury of knowing, let alone the confirmation of their unity with galaxies, nor their magnetic fields. Looking at the black hole, I will superimpose a reality atop our own and start with the hypothesis that when we here on Earth are looking at the bottom of the black hole, we are in fact looking at the top of our reality. Let me say that again. Looking at the black hole, I will superimpose a reality atop our own, and starting with the hypothesis that when we here on Earth are looking at the bottom of the black hole, we are in fact looking at the top of our reality. And I will call this the cascading universe, where each black hole, massive enough, has the potential of crystallizing into its own universe. Now we can finally start at the top. Compression into the black hole. Whee! Down, down, and down we go. To understand this realm of reality, you have to grasp onto something solid. You're in a virtual world of flux. You're in a wormhole, and energy arcs in the grandest of nebulas are swirling, shimmering, and attempting to solidify, only to decohere and recohere. You are in the realm of entanglement. And ultimately, entanglement energy is the energy of the universe. Everything forever entangled in which it originates, all matter cascading from a quote-unquote true creation, from a single source, consciousness, or God. With this said, the takeaway is that everything is connected and that everything is entangled and that all is entanglement energy in some form or another.
So, think of electrons as being connected to all other points in the universe by invisible strands.
To elevate our perspective from this deep dive into the realm of consciousness, we need to look at the universe from a perspective that reality itself is a matrix of sorts, and that underlying our ordinary lives there are realities and physicality that do go far beyond our human brain's comfort zone. As matter compresses into the black hole, as the hole gets large enough, let's say 10 billion times the mass of our sun, this value is a placeholder, undetermined or indeterminate. The core of the black hole crystallizes and falls in dimensions and creates a quote-unquote dimensional shift. I will skip over the exact details of this whole process. I haven't even begun to explain what dark energy is yet, so I will round back to this at the bottom. But just know that from the universe the black hole fell, it is still in that universe. It is still entangled in the universe from which it originated. But the mass has fallen into a new quote-unquote level plane in the dark energy field. Okay, so a quick note. Level plane and universal membrane are two things superimposed upon each other, though they are not the same. The level plane is the dimension, but it is not space. And in theory, it is nothing or infinity. That is to say, the level plane is the level that space falls into, but it is not space. It is more a placeholder. If you were running a computer simulation and you said all traffic going in and out of this area is tagged with an orange marker, nothing could go into the level plane and there would be no tags. Or infinity could go into the level plane and all would be tagged with an orange marker. The universal membrane, on the other hand, is space. This is the dark energy field in its entirety within the level plane. Once matter has broken free and fallen in dimensions, it is met with nothing. No energy, no dark energy, space, gravity, or time. When we have that first pinpoint contact with this new level plane, as the mass of the supermassive black hole crystallizes into its own universe and falls through the quote-unquote dimensional shift into a new level plane and creates a new universe, there is nothing at all. And therefore there is no gravity, no time, no space, no energy, nothing at all to hold the mass of the supermassive black hole together, and we get a bang, a big bang. But actually there is no time, space, or gravity, so the mass of the supermassive black hole has nothing holding it back, nothing holding it together. And so as it expands outwards, there is nothing to measure, nothing to determine its rate of expansion, but it does decompress, and in doing so expands outwards to encompass its maximum expansion. And in doing so starts to create space, time, and gravity, all of which I will explain. Continued, Orion Michael Guy.
So we can't really talk about the t=0 beginning of time because that moment is lost in our ignorance about quantum gravity and inflation and whatever other crazy theory we haven't figured out yet.
Okay, so this is part 1 of the 4 main parts of this series, and I just wanted to highlight a couple of points here. I'm going to keep this very concise because I want to follow this up with the other parts and of course the follow-ups to those and the additions. Basically, the concept is this. And I wrote this in 2015 and we're now in 2021, and I've evaluated and adjusted my theory, and I've come to grasp with a lot more information and an understanding of what's happening. But just to explain this particular part right here, and of course I will continue to make these parts, and keep watching because there's a lot more information that you're going to want to get, and then this stuff is going to become even more crystal clear. So what you're going to want to do is probably watch the series at least twice to fully understand this particular series. And this is just going to be one part that's going to be added on to my Majestic Crystal Universe playlist, and is just going to be more information that you can use to understand the universe and how it works, and my attempt to convey to you, I guess you could say, the theory of everything. Okay, so I've learned a lot since I wrote this paper in 2015. Now we're in 2021. And one of the things that I wanted to highlight and emphasize is that when you have the compression of a massive object that is able to have a dimensional shift where it basically is a singularity, it's a black hole, and it creates a new dimension, and we have that pinpoint quote-unquote first contact where the matter and energy from this universe becomes strong enough and the core itself crystallizes to create its own new universe, and you have that quote-unquote pinpoint point where what we would traditionally call in physics the Big Bang, where there was this point in space and time where basically energy burst out of nothing, and within fractions of a second there was this huge expansion, and then that expansion as this very highly energetic plasma basically expanded outwards in fractions of a second, and then it slowly started to cool, and then the plasma itself went through a solidification process where it started to differentiate itself from matter and space, and so you actually had space, distance of energy pulling away from each other. So you had a solidification, and you had space basically and matter starting to form into what we traditionally call, what we traditionally see in the universe. This is the point where gravity starts to take hold, time starts to kick in. I will elaborate more on this in upcoming videos in this series, but time is the interaction between energy and dark energy. The key point here is that at that pinpoint moment when the universe above us crystallized and created what we consider the Big Bang, space, time, energy, none of that, gravity, none of that existed. So you can't really measure the expansion rate in the same chronological terms that we consider right now in the universe. Back then, the gravity, matter, and space were all completely different. So the rate of time was non-existent or different, almost non-existent at the very, very beginning. So whatever that expansion was, we could say it all happened in a fraction of a second. And to us, that's mind-boggling that all of this matter and energy could expand from a pinpoint point outwards to this, encompass this massive, unimaginable amount of space, all in quote-unquote fractions of a second. There was no time back then, so it could have taken a trillion years. There was no reference clock that we can really understand from our current methods of measurement. So so they do say that it was a Big Bang and it all happened in fractions of a second, but you have to understand, back in the very beginning of the universe, there was no time. So to say that it happened in fractions of a second is, technically, you could say that that is correct because there was no time, so it all occurred in such, once you start to calculate time, it all happened very, very fast. I guess that is kind of a way of explaining it. But another way to understand it in your head is that time wasn't occurring. There was no matter, there was no energy, there was no space, and there was no time. And then what happened is the universe above us crystallized and came through a dimensional shift, creating this new universe out of absolute nothingness. That means no matter, no energy, no space, and no time. And so that mass, that energy did expand outwards almost in a calculation, in a quantum simulation. You could say it's a quantum calculation and it's a quantum simulation. And at the very beginning of the quote-unquote simulation, time didn't work the same that time works right now. And in a billion years from now, time will not work the same way it works right now. If the universe keeps expanding and the overall gravity of the universe keeps changing and shifting, then the rate of time as we know it will change. But the thing about relativity is that doesn't really matter because everything is relative. Whatever planet or surface you're on, it's all relative to that particular core of that particular planet. So those are just a couple of things that I wanted to throw in at the very end of this particular part 1 video article. Stay tuned. I'm going to have part 2, 3, 4 coming up, as well as several other parts in this series, and I think you're really going to enjoy them. Thanks for watching. Stay tuned. I will have more for you shortly. Thanks for watching.